पिला माने मु आज पढ़ाई चाहूँगी तुम मानक कोऑर्डिनेशन कंपाउंड्स कोऑर्डिनेशन कंपाउंड विषय जोड़ा केतरे बहुत टर्म अच्छी से गुड़ा कहि तार नोमेनक्लेचर कहि यही सेशन रे प्रथमे तुमको वेलकम कर क्लास पाई लेट अस स्टार्ट व्हाट इज ए कोऑर्डिनेशन कंपाउंड बिफोर गोइंग टू द कोऑर्डिनेशन कंपाउंड I will speak double salt and coordination compound. You should remember one question asks write the difference between double salt and coordination compound. Double salt this way or this way I am writing this way. Double salt. In the double salt I am writing two examples potash alum. Potash alum formula is K2SO4 L2SO4 whole 3 24H2O. Similarly, you may write canalite KCl MgCl2 6H2O and complex part I am writing complex K4 FeCN6 in the square bracket. Now my point is what is the difference between double salt and complex? When the double salts are dissolved in water, they break into constituent ions. जदि आम पानी को पकईदबा ये पूरा भांगी जीव भांगी जाए सबूरा कौन हो आयन हो सपोज यू ब्रेक पोटाश alum you will get the ion of K plus SO4 minus minus L plus plus, whereas if you break this one this complex part in the square bracket even the complex part you dissolve in water. By dissolving water you cannot get the ion of Fe plus 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 or Cn minus. You will not get आप पाइबा नहीं किंतु एक केस रे हमें पाइबा ताने व्हाट द डिफरेंस बिटवीन डबल सॉल्ट एंड कॉम्प्लेक्स मोस्ट ऑफ द टाइम 2 मिनट रे क्वेश्चन पड़े 2 मार्किया क्वेश्चन आकु तो समय 2-3 मिनट करिवो लिखिबो एवं 2 मार्क क्वेश्चन इन द 2 मार्क्स क्वेश्चन रे यू विल स्पीक by you write when double salt dissolved in water it give its constituent ions like double salt potash alum give K plus sulfate ion and L plus plus plus, whereas complex cannot give its ion when dissolved in solution, so it retain its identity. Complex retain its identity where the double salt does not retain its identity, does not retain its identity. Define this. There are 2 points. When these dissolve in water, these give constituent ions. When these dissolve in water, they don't give constituent ions. Second point, it does not retain its identity, it retains its identity. Then we have to go discuss about Warner's coordination theory, which is most important. एवं 3 नंबर क्वेश्चन आसे राइट द पोस्टुलेट्स ऑफ Warner's coordination theory. Warner's coordination theory. The first postulate is metal possess 2 types of valence. Metal possess 2 types of valence. One is primary valency, and the other is secondary valency. तर प्रति मेटाल 2टा valency अच्छी, गोटे primary valency, another is secondary valency. Second point, the primary valency is satisfied. The primary valency is satisfied by negative ions. बुझेबे तापर number third, secondary valency are satisfied by negative ions, neutral molecule, even positive ions also, So first point, metal two types valency, primary, secondary. Primary valence satisfied by negative ions, secondary valence are satisfied by negative ions, neutral molecule, even positive ions. Let us discuss this matter. Suppose you take a complex CO NH36 Cl3. It is a complex. This part is complex. Square bracket is mentioned the complex part. And Cl3 primary valency. This is your primary valency. Cobalt is +3 state. These three is the cobalt has primary valency or primary valency 3, which is ionizable. Important point, this is ionizable. Suppose COCl3, imagine COCl3, cobalt give +3 CO +3 in aqueous solution, 3 Cl minus. So C +3 and minus here give जो 3 valency of cobalt, this is called primary valency of cobalt 3. But number of molecules that is coordinated to the central metal ion is 6. Number of molecules that is coordinated to central metal ion is 6. So this ammonia number is 6 molecules coordinated to the cobalt. So this cobalt has secondary valency is 6. Your secondary valency is 6. While the primary valency is 3. Now this is non-ionizable. You bhangile ion habani. Bhangibani. It is non-ionizable. One is ionizable, another is non-ionizable. Then we have to study of special arrangement. Fourth point. Arrangement. If coordination number, which is called secondary valency, that is called coordination number. जहाँ secondary valency सही है. Coordination number if 6, the structure is octahedral. I will detail discuss afterwards. If coordination of 4, coordination number is 4, that is either square planar or tetrahedral. Octahedral is 6, that is octahedral structure. If 4, that is either square planar or tetrahedral arrangement. This is the Warner's theory. How to verify the Warner's theory also studied taking the complex of CO NH36 Cl3. treated with silver nitrate solution. Silver nitrate solution. What happens? Let us see. If the complex is 3 chlorine atoms, if remaining outside of the sphere, then it is ionizable. It gives 3 HCl precipitate. From 1 mole of the complex, 1 mole of the complex we get how many moles? 3 moles of silver chloride. That indicates that 3 chlorine atoms are ionizable. Hence, we get 3 chlorine atoms precipitated as 3 silver chloride. Similarly, if the complex is like this, CO NH3 Cl Cl2 treated with silver nitrate solution. Here the coordination number is 6 because you look here 5 ammonia and 1 chlorine. If there is 5 ammonia and 1 chlorine is coordinated to the cobalt, hence the coordination number is 6 or the second valence is 6, but the primary valence is 2 because in this case it gives the form like this CO NH3 it cannot break into constituent ions, hence it gives plus 2 Cl minus. So hence we get 2 moles of silver chloride precipitate. If it gives 2 moles of silver chloride precipitate of taking this compound CO 6 ammonia and 3 Cl, then the structure of the complex is like this CO NH3 Cl. If we get 1 mole of silver chloride, then what happens? Look at here CO NH3 4 Cl2 Cl treated with silver nitrate. Here we get the precipitate as 1 mole of silver chloride, 1 mole. Hence, this 1 chlorine remain outside of the coordination sphere. Since 1 chlorine atom remain outside the coordination sphere, it gives the precipitate of 1 mole of silver chloride. This was verified by what not? Let us start. CO NH36 Cl3. So this part is complex part. This is outside of the coordination sphere. They remain non-ionizable. It is non-ionizable, it is ionizable. So it gives total number of ions, it gives CO NH36 plus 3 Cl minus. So total number of ions is is equal to 3 plus 1 is equal to 4. Suppose the complex is all right. Suppose you take like this CO NH36 NH35 Cl2 complex. It gives the complex CO NH35 Cl plus 2 Cl minus. The total number of ions will be here 2 plus 1, that is equal to 3. Now you take this one CO NH34 Cl2 Cl. This complex gives the ions CO NH3 4 Cl2 plus Cl minus. Total number of ions 1 plus 1, this is equal to 2. So conductance we can measure. This the conductance increases from this and this. It is 4 ions. It is the most highest conductance value, it is then 3, then 2. So from this, by the conductance measurement, we can find out what is the nature of the complex or nature of the coordination compound which remain outside of the coordination sphere. Let us discuss then some terms in coordination compounds. Some terms in coordination compounds. Some terms in coordination compound. Number 1, central metal ion. Suppose you take the complex CO NH36 Cl3 complex, take this one. Here this cobalt is the central metal ion, because cobalt remains there, 6 ammonia molecules are surrounded there. NH3, 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 and 3 Cl remain outside the coordination sphere. It is a central metal ion. Then come to this part. This part is called the molecules which are coordinated to the central metal ion. The molecules that are coordinated, molecules or ions that are coordinated to the central metal ion is called ligands. That is called ligands. One is central metal ion, then come to ligands. In going to the ligands, there are different types of ligands are there. And what is the ligands? That is the molecule or ion, the molecule or ion coordinated to the central ion or atom, central atom or ion are called ligands, So these ligands are different types. Suppose you take ammonia, that is called unidentate ligand. Unidentate means the ammonia can linkage through only nitrogen. One nitrogen is there. By the lone pair electron, linkage takes place to the central metal or ion. So in the linkage takes place to this lone pair electron goes to metal, hence only one way, through nitrogen, hence it is called unidentate ligand. Suppose you take ethylene diamine, CH2, 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 NH2, CH2, CH2, NH2, let us take NH2, ethylene diamine. In the case of ethylene diamine, here is one lone pair electron, here is also one lone pair electron, so one molecule can coordinate the two positions. To the two positions, that is called, hence this is called, two position means didentate ligand. The ethylene diamine is a didentate ligand. Why? Because this molecule, one molecule can coordinate in the two positions, thence it is called didentate. If more than two, that is called polydentate. Suppose EDTA. Let us discuss EDTA. It is a polydentate ligand. Ethylene diamine tetraacetate. Ethylene diamine tetraacetate. I am writing the structure. EDTA structure is CH2 ethylene, CH2, CH2, N CH2 CO minus CH2 CO minus CH2 CO minus CH2 CO minus COO minus COO minus. So here the linkage takes place through one molecule is there, that is called EDTA, ethylene diamine tetraacetate. In this case, here is one lone pair electron are there, here this position, here is one my negative charge. Linkage takes place 1, 2, 3, 4, 5, 6. So one molecule can link through 6 positions, therefore it is called hexadated. परीक्षा बहुत सम परीक्षा पड़े EDTA. What is the maximum coordination number of EDTA? Hexadated ligand, which can, it is coordination position is one molecule, position is 6. So when this coordinate central metal ion, the coordination number of the metal will be 6 from one molecule of the ligand. That one is unidated, the second is didated, then polydated. It is called also polydated ligand. More than 2, 3, 4, 5, 6 like this. One is ambidated. Ambidated ligand. Suppose you take nitro group. Nitro group can link either through nitrogen or through oxygen. Either through, if the nitrogen linkage to the metal ion through nitrogen, or we may take like this, O linkage through O, linkage through oxygen. 2 ways. One molecule can link through 2 molecules, one nitrogen and oxygen. So this ligand is called ambidated ligand. It is called ambidated ligand. Then what is monodated, didated, polydated, and ambidated ligand. Then homoleptic complex, homoleptic complex, but a heteroleptic complex. Heteroleptic complex. If all the ligands are same, suppose CONH36, this complex plus 3, it is a complex. So this is called homoleptic. If another ligand are there, CONH35Cl, ligand, 2 types ligands, one is NH3, another is Cl. The 2 types of ligands. If only same ligand is there, that is called homoleptic. If different types of ligands are there, that is called heteroleptic complex. And this square represents the coordination sphere in the complex. These are the only terms. One is central metal ion, the other is ligand. Ligand again different types. One is unidated, didated, polydated. Then come the homoleptic complex and the heteroleptic complex. These are the some terms involved in the formation in the complex compound or coordination compound, in the complex or coordination compound. Then we'll start important point, that is nomenclature of coordination compound, nomenclature, which is most important. Nomenclature by IUPAC system, IUPAC system. International Union Pure Applied Chemistry. How to name the complex? That the following points. Number 1, first find out cationic part, which is cation, which is anion. First you take cation part, cationic part. First name the cationic part. Name करिए first है simple way, little बुझे भी था पड़े. Name the cation part को अलग कर दो, cationic part. Second point is naming of ligands. Naming of ligands by alphabetical order. Alphabetical order. Which is important point. This is naming first cation part, then naming of the ligands. Third point, prefix di, tri, tetra, 4, 2, 3 and 4 respectively, so on respectively. For complicated ligands, which are complicated I will discuss later. Complicated ligands, bis, tris, tetrakis, 4, 2, 3, 4 and 1, 2, 3, 4. Fifth point, central metal ion. If the complex cation, if the complex is cation, then first name the ligands name, alphabetical ligands name, then name central metal with Roman letter in parenthesis. Detail bujhebi in parenthesis. If the complex is anion, 6 point, if the anion complex is anion, then we have to write suffix is all the same. The suffix will be ate with Roman letter in parenthesis. Now we will discuss the following points. How to name the coordination compound or complex. Let us start. Suppose you before starting the name of the elements, name of the ligands have to mention. What is the name of the ligands? Name of the ligands, we have to write some negative ligands. First, negative ligands. Suppose Cl minus. Negative ligands, our suffix will be O. Our suffix is O. Suffix is O. Suppose Cl minus, the ligand, Cl is a ligand. So this is chlorido, chlorido, suffix is O. Br minus, similar manner, bromido. Similarly, you may write cyanido, Cn minus, cyanido. Some of the ligands I am mentioning, OH minus, hydroxo, SO4 2 minus, sulfato, sulfato, SUL, PHATO, sulfato. Similarly, NO2, दो प्रकार, either linkage through nitrogen or oxygen. If linkage through nitrogen, then it is called nitrito N, capital N. If linkage through oxygen, then nitrito, NITRITO, nitrito O. Either linkage through oxygen or nitrogen, which is ambidextrous ligand, nitrito O or nitrito N. It is a negative ligand. Some of the negative ligands, some neutral ligands, water, H2O. H2O, it is neutral. It is called aqua. AQUA, aqua. NH3, simple. It is called amine. Like this, some of the ligands name is like this. Now we'll discuss how to give the name of the coordination compound. Basing on this. We take the simple compound, we take CO, NH3, 5, Cl, Cl2. Let us discuss this complex. So this is the complex part, and this is the outside of the coordination sphere. So this part is anion, simple KCl. In KCl, K is cation, Cl is anion. Similarly, this part is complex part is here. Complex part is cation, and this part is anion. So first point I have told you, the naming of complex is given as complex part, cationic part. In the cationic part since complex, so we should write first the name of the complex. In the name of the complex, there are how many ligands are there? There are two types of ligands there. One is Cl, another is ammonia. Two types of ligands are there. So it is chloride is Cl group and NH group. I have told you write the ligands first. So it is alphabetical order. In the alphabetical order, we may write C, chloride as chlorido. Her name is chlorido, and the name is amine. It starts from A. This starts from C. So in the alphabetical order, we have to first write down amine group. In the amine group, it will be pentaamine, small p. So we write in small. So pentaamine. Pentaamine means this is 5 molecules are there. Since 5 is there, it is mentioned 5. Pentaamine, chlorido, pentaamine, chlorido, cobalt kete ho. Find out the how can oxidation number kemti bahar kariba. How can find out the oxidation number here? Suppose it is X plus ammonia, neutral molecule 0, minus 1, minus 2 is equal to 0. So X is equal to 1 plus 2, that is equal to 3. Therefore, the oxidation number is 3. So we may write pentaamine, chlorido, cobalt 3, Roman letter in parenthesis, bracket with the likha padibo, cobalt 3 chloride. Since the complex is cation, let us take another example. Some of the examples we will discuss. Potassium K4 FeCN6. Potassium K4 FeCN6. So this part is complex. This part is cation. So first you name the cation. Cation is potassium. So we have to write down potassium. सेटा भूल पिले करिवनी सीधा केटाइन को अलग कर दबा एनाइन को अलग करिवा. Since K is there, it is potassium first. Then we go to the complex is find out complex is anion. So the complex ta anion अछि tal kar hamo tale we have the ligands. First write the ligands. Hexa potassium hexa लगे लगे सब लगेबो. हेक्सा सियानिडो cyanido, then Fe there, ferret. Suffix is at. I've told you point ferret. Oxidation number 3 or 2? 2. How 2 comes? Let us see. Plus 4. Kerala 1 plus 1 plus 4. Cn is minus 1. Minus 1 into 6, that is minus 6. It is x. Plus 4 plus x minus 6 is equal to 0. Hence x will be plus 6 minus 4, that is equal to 2. That is called oxidation number. So oxidation number is utilized Roman letter. We can write 2. We can write that is Roman letter is 2. So this name of this complex will be potassium hexacyanido ferret 2. If you take K3 FeCN6, similarly we take K3 FeCN6. Similar manner, cation and anion. So this part is cation and this part is anion. So anionic name is first, cationic is first. So it will be potassium hexacyanido ferret 3. It will be potassium hexacyanido ferret 3. Kahin 3 ala dekho? It is plus 3. 3 ke, gote ke plus 1 plus 3. It is x. Cn is minus 1. H is minus 1. That is plus 3 plus x minus 6 is equal to 0. Hence x will be plus 6 minus 3, that is equal to plus 3. Hence the name is potassium hexacyanido ferret 3. In Roman letter, we can write 3, that is ferret 1 1. Roman. Now what name of this complex will let us Cr CN5 NO2 Cl3. How to name this complex? So this complex contains the ligands of Cn NO2 through linkage nitrogen. It linkage through nitrogen. ON only, not written, N only, N is written. So we may write first ligands. One is comes cyanide ligand. First find out what the ligand, cyanide. Cn, that is called cyanido. The another ligand is nitrito-N. Nitrito-N. And it is chromium. So first find out whether the complex is cation or anion. If the complex is cation, then first name the complex part, then go to the anion part. Hence it is the complex is first find out it is cationic part. This is cationic part, cation, and this is part is outside this sphere is called anion. So in the cation part, hence we may write this compound like this, alphabetical order. The ligands are named in alphabetical order. So it will have C and N. C comes first, and therefore we may write Cn. How many molecules? 5 molecules, and is called cyanido nitrito-N chromium. Not at zinc cation, we can't add T. T I will लिखिबानी. We may write chromium खाली. Name of the element. Chromium. केते बाहर करिबा. So this is let X. Oxidation number X. So this is Cn is minus 1. प्रति Cn वाला minus 1. Then 5. X minus 5. X minus 5. NO2 minus 1. Minus 1 is equal to each chlorine minus 3. Minus 3 is equal to X. This is X minus 5. This is minus 1. CrCN5 NO2. So this will not be a cation complex. Oxidation number haba nahi. एटा को मैं राइट एटा गोटे एनायन कॉम्प्लेक्स हम कहीं बिले देख जदि आम ये कॉम्प्लेक्सटा Cl3 करवा ताले केते आसी जीव देख x -5 -1 again this -3 is equal to 0 x is equal to 9 so this complex does not exist this type of complex does not exist so it will be like this hey pare dekho bile k4 cr ba k3 dekhiwa k cn5 NO2 whether this complex exists or not let us see K3 we write K3 simply write K3 if it is K3 then chromium will be which oxidation state it will be K3 plus 3 chromium X plus X minus 5 minus 1 that is equal to 0 so X will be plus 5 plus 1 minus 3 that will be plus 3 state so this type of complex can exist but this complex coordination number cannot be 9 of the chromium but question pake the bholi rakam wrong question wrong it kai hai paribani so it is complex will be anion this type the complex will be anion and the name is will be potassium first cation part is mentioned potassium will be nitrocyanide first cyanido kete cyanido penta cyanido nitro suppose n so link direct likhi you know chromate it will be chromate CHROMAT chromate 3 some complicated ligands जो ligand रे ट्राई थिबो सब ग्रुप रा मिस लिखाई थिबो से ग्रुप रा हम डाई लिखि परिबा नाही सेट लिखा जे 20 सपोज एथिलीन डायमीन एथिलीन डायमीन फॉर्मूला is CH2 it is bidental ligand CH2 NH2 CH2 NH2 ethylene diamine in the case of ethylene diamine so it is already diamine die ଅଛି already ଆମେ ଆଉ die ଲେଖି परिबा नाही it is like a dita molecule 20 तीनटा दिले 30 like this so it is if one molecule two molecules are there that is called bis it is simple we write that En that represented by En it is term En CO En3 complex like CON3 Cl3 complex how to give the name of this complex En is ethylene diamine since it is ethylene diamine we may write like this so the complex part is cation first find out which cation and it is cation and this part is anion we have to mention the name first cation part since ethylene diamine is a complicated ligand it is not tri likhi pariba it likhi ba tris you may write tris bracket write down ethylene diamine tris ethylene diamine cobalt 3 chloride question may ask what is the coordination number of cobalt here what is the coordination number or secondary valence what is the coordination number of cobalt here तल पिला भाबियो कोन तीनटा मॉलिक्यूल अछि तीनटा हवा कथा काहे कि बिकॉज़ एथिलीन डायमीन इज ए डाइडेंटल लिगैंड En is a didental ligand since it is a didental ligand each molecule has two positions therefore the coordination of cobalt is 6 the coordination number of cobalt is 6 not 3 3 like dele mark paibani It is coordination number called 6. Simple another we may write. How to write the compound? The two complexes are there. Suppose we may write Cr NH3 How to name up this complex? And let us say Cr NH3 and CO CN6. Two complexes are there. In the two complex, this is +3 chromium. It is my cobalt remains cobalt CN6. It is plus total is +3 part, and it is -3 part. Total complex. Here the complex is cation, and this complex is anion. When the both complex, two complexes, one is cation and anion. First we write down name of the cation. First we write down the cationic part. Cationic part. How can I write the cationic part? So the cationic part is mentioned like this, hexaamine. So this first write down hexaamine, chromium 3, then this is anionic part, will be hexacyanide, বুঝম পরীক্ষাতে এগুলো আছে hexacyanide cobaltate 3. The name of this complex. It is a total. If one complex is cation, one complex is anion, first write down complex cationic part, then go to the anionic part. So this all about a nomenclature. Now some of the questions may be asked in the exams. Number 1, distinguish between secondary valency and primary valency. দুই মার্কের কোশ্চেন এই পরীক্ষার পরে। Distinguish between secondary valency and primary valency. Distinguish between double salt and complex. Double salt and complex. এমনি বহু সময় পরীক্ষার পরে উসমা ভিতরে nomenclature পড়ি পারে, উল্টা পাল্টা পড়ি পারে, তুমি স্ট্রাকচার লিখি পারে। এমনি পরীক্ষার স্ট্রাকচার পরে সাপোজ write the structure of chlorido pentacyanide chlorido pentaamine write down. It will easily pentaamine cobalt 3 bromide. How can I write the structure of this compound? Cobalt 3 bromide. So first find out this part is complex part and this part is outside is pure, cone is pure. So this is complex is itself is not AT, it's only cobalt 3. So it must be a cation complex. It must be a cation. Again, ta na da again likhi rakhiyo padibo. Ta structure I kariya padibo. It is cation. Since it cation, chlorido pentaamine में एमती सीधा लिखले भी पेंटामिन आगे रहिबा पेंटामिन बिकॉज एमिन टा फास्ट क्लोरिडो ता पछुक आसीबो पेंटामिन क्लोरिडो परिकार पल्ला मन कर एटा पेंटामिन क्लोरिडो कोबाल्ट 3 ब्रोमाइड काहे कि पेंटामिन आसिला बिकॉज एमिन एमोनिया कम्स ए फास्ट अल्फाबेटिकल ऑर्डर पेंटामिन क्लोरिडो सी तापर सी हम आगे क्लोर लिखले भूल हबो पेंटामिन क्लोरिडो कोबाल्ट 3 ब्रोमाइड हाउ कैन राइट First write down the central metal ion is cobalt, CO. Then comes to pentamine, NH3 5, chlorido Cl, bromide. देखिए I don't interesting bromide, Br. कितना bromide रहेगा? हमारे cobalt में +3. It written 3 is given there. Since 3 is given there, so let us X. केतरा ब्रोमाइड भाग करि परिबा सपोज इट Br 2 हेले देखो -1 अछि इट विल कम X + 0 -1 -2 that will 0 X will be +1 + 2 that is equal to 3. So pentamine, chlorido, cobalt 3, bromide cation part आगे बाहर कर दलो, then go to bromide outside. Br2 not Br3 ले भूल अब. Br3 ले कौन अब? -3 is what? 3 ले 4 आसिबो. अब दिया 3. Since 3 is given there, we will write down 2 bromine group. एटा एमती बुलेई पचारिबो. Either name कर पारो किंबा structure पकाई पारे. Write this naming of the compound. I am writing CR En2 BrCl NO2 complex. How to name of this compound? Total is complex, not outside किसी नहीं. किमने ना दबा. Cation हो किंबा neutral हले आमे तक कौन first ना दबा ligands. Ligands are there En, that is ethylene diamine. 2 BrCl करो. 2 7 आ जाऊँगी 6 करो. Cr En2 BrCl 6 write down. Plus it write down here Cl. Now how to name of this compound? Ligands are, first find out the ligands. What are the ligands? Ligands are En, ethylene diamine gote. Ethylene diamine. Bromide. Chloride. So first we give the name C, B, E. So alphabetical order. In the alphabetical order, first come B, then C, then E. So if you write first bromide group, one bromide there, tale bromido. Bromido. Then we come C, chlorido. Chlorido. Then we come to bis, because 2 molecules are there, bis. Ethylene diamine. Ethylene diamine. bis ethylene diamine. Chromium के देखिए बाहर करीबा. X ethylene diamine neutral 0 -1 is equal to 0. So X is +1 +1 +1, that is +3. Diamine, chromium 3 chloride. Name of this compound. যেকোন সে পড়ু পরীক্ষারে তাহলে গোটে ক্যাটায়ন পার্ট অ্যানায়ন পার্ট বাহার করিও পড়িব. তাহলে we discussion today what is the coordination compounds, how they differ from double salt, distinguish between double salt and complex. कारण double salt का भांगी देले आयन हो जिवो, इजीली वाटर डिजॉल्व करो आयन हो जिवो, किंतु complex सहजरे भांगी परिबो नहीं. Okay, which retains its identity? Complex retain its identity, whereas double salt does not retain its identity in water. Then got the Warner's theory. In the Warner's theory, that valency, primary valency, secondary valency. Primary valency satisfied by only negative ions, while secondary valency is satisfied by either positive ions, negative ions, even neutral molecules. Then we'll discuss some terms with the central metal ion, ligands, unidental ligands, didental ligands, polydental ligands. Then go to the nomenclature. In the nomenclature, we discuss some points. After this, ये कौन सी पहले पढ़कर कर पारिबो, कैटायन के नाइन बाहर कर दबो, बाहर करके जे कौन सब कर पारिबा. So this is all about your coordination compound nomenclature. Next class, I will discuss bondings of coordination compounds, bondings and isomerism. Thank you.